So let's look at how we could apply these trig ratios in a real life situation. So we have a group of conservationists and they need to calculate the angle of elevation of a riverbank of the North Saskatchewan River. Now, as you saw in the video before, we could use what's called a transit. Not everybody has a transit at their disposal, so what they've chosen to do was set up a right triangle using two measuring poles. So you can see here in the picture, they're setting up these measuring poles, similar to the poles that you would use if you were using a transit. So if they measure that the vertical height is 64 centimeters and the horizontal height is 50 centimeters, we want to figure out what is the angle of elevation of the riverbank. So you can actually see the triangle that they are creating here. So if I draw this over here, so if I'm going to draw in my triangle so you can see it. Okay, there's our angle, our diagonal right here, our hypotenuse. Okay, and as we said that the vertical was 64 and the horizontal was 50 centimeters. And we are looking for the angle of elevation. Now, an angle of elevation is, remember that the angle of elevation is when we are looking at the parallels, right? So here's our parallels with our ground and our horizon. That was neat that that changed, right? So we're looking for the angle of elevation, which if this is our ground would be here, which then translates up to this angle right here in our triangle. Okay? And if you don't see that, what we can do is we can redraw this triangle outside of the photo, okay, in the way that we're used to seeing. And we know that the horizontal is 50 and the vertical is 64, right? So here's our angle x, that angle of elevation. So now we want to set up an equation to solve for x. So we're going to look at what we have. We have the opposite side and the adjacent side. So remember our trig ratios, so ka, toa. Which one will we be using here? It should be tangent, right? So we're going to do the tangent of x is equal to 64, which is the opposite, over the adjacent of 50. Okay, now remember, in order to solve for the angle, we have to do the inverse of the tangent. So we're going to be calculating the inverse tangent of 64 over 50. So if I bring up my calculator, my graphing calculator, let me hit to run that. Okay, and what was it again? It was the inverse tangent. So the inverse tangent of 64 over 50. So the angle of elevation is about 52 degrees. Okay? So let's look at one more example. This one's a little more complicated. It says, from a height of 50 meters in his fire tower near Lake George, a ranger observes the beginnings of two fires. One fire is due west at an angle of depression of 9 degrees, and the other fire is due east at an angle of depression of 7 degrees. What is the distance between the two fires to the nearest meter? Okay, so we're looking, so what we have here, we have a ranger up in his tower, okay? And the ranger, let's say he's right here. We know that this height is 50 meters, okay? And we have our horizon like this, it goes parallel out, okay? So he sees this fire happening due west, okay? The fire due west has an angle of depression of 9 degrees. So if he's up here looking at a height of 50 meters, he's looking down at the fire. He sees the fire happening at a 9-degree angle of depression, okay? And then we have the ground, which is parallel to that horizon line. And we're going to assume that the tower is perpendicular from the ground. Then we have another forest fire happening. There's the fire. Fire, right? And he looks over at this fire at an angle of depression of 7 degrees, the one to the east. Okay? So there's another right triangle that we have created. Now, we want to find the distance between the two fires. Well, we're kind of like at this middle. Now, we don't know it's exactly middle, but what I'm saying is we're at this middle ground. So there's a separation from us to the left, us to the west, and us to the east fire. So we're going to look for two values. Let's call x and y. Now, we want to solve for those two values and then add them together to get the total distance. So remember angle of depression. If you remember that these lines are parallel, the horizon is parallel to the ground. That's our assumption, okay? So this 9 degrees is technically outside of the right triangle for which we're measuring with that 50, okay? So if this is my right triangle here, 9 degrees translates down to 9 degrees right down here of my triangle. So now if I want to solve for x, I have the opposite and I'm looking for the adjacent. So that would be another tangent. So we have the tangent of 9 degrees equals 50 over x. Now on your calculator, when we're solving for this, remember that we end up actually dividing 50 divided by the tangent of 9. Okay, so you should get x is approximately equal to, and it does say round to the nearest meter, so I'm just going to round to the nearest meter for everything. So this is about 316 meters. So if I come over to my other side now, this triangle that's blazing on the east, okay, so here's my right triangle. There's an angle of depression of 7 degrees. This angle of depression is alternate interior with this angle here, which is the same as the angle of elevation. Remember, angle of depression is congruent to the angle of elevation. And we're going to use another tangent ratio. So the tangent of 7 degrees is equal to 50, which is the opposite, over y, which is the adjacent. So again, we're dividing the 50 divided by the tangent of 7, and we get 400. So y equals about 407 meters. So if we want the total distance, we're going to add those two numbers together. So 316 plus 407 is going to equal about 723 meters. That's the distance between each fire. Fun, interesting, very interesting.